So, welcome everybody. I'm Jason Reed. I'm one of the co-founders here at Tabular. I'm very happy to be joined today by Vicky Bukta, who is a senior product manager here and was previously a data engineering manager at Shopify. She's going to be talking about CDC in depth today, change data capture, all the good, bad, and ugly of CDC. We are recording this session, so just it's been recorded. It will be sent out after this is complete. We also encourage you to have questions, but we're going to hold them for the end. So if you have any questions as Vicky's going along, you can put them in the Q&A section of the webinar, and we will address them at the end. Or you can just hang on to them and we'll come back around after the presentation. And if you're having any technical issues of any kind, just drop me a note in the chat and I'll help you get those unblocked. And without further ado, I will turn it over to Vicky. Take it away.
Hey, hi everyone, and thanks for coming for this webinar, Everything You Wanted to Know About CDC. Oops. And there's a lot of different topics that we'll cover today. We'll start from the bin logs, from understanding how the relational database changes are being made. We'll talk about how do we get that data out of a relational database and then into some sort of data lake, whether that's Iceberg or something else, and give you some opinionated architecture choices along the way. And the purpose of this webinar is not to talk about how to use any of like a specific tool or make recommendations on tools, but more about the overall architecture decision-making throughout the process and understanding the mechanics of CDC and how data is captured and what it actually represents. So why do you even want to do change data capture? So there's a lot of reasons, and it's usually around wanting lower latency data ingestion, wanting more accurate data ingestion, but also having a way to capture all the different operational changes to a relational database that can be hard using different mechanisms. So let's get into the basics. So at its core, what CDC is all about is around capturing those database changes. So you have an application that's modifying data in the database, inserting data into your database. We want to get those out into some sort of analytical storage so that you can do analysis on it. And there's essentially two methods of doing this. We can do it a batch method or a streaming method. So just a quick recap on what batch looks like. And if you're interested more in detail about batch, our last webinar on ingestion went into a lot of detail on this. But when we do batch ingestion, we do something called statement-based replication, which is when we run a series of queries against a database to get data out. And that can look a lot like this. Select star from a table. Maybe you have a where clause to select just a subsection of that data so that we can run things incrementally. There's a number of problems that we run into when we do this. One is the issue about possible missing updates. When we run incrementally like this, we rely on some sort of timestamp column, like an updated at key. And the problem with this field is it's something that is actually manipulated or can be manipulated by an application. So if your application that's touching the database is not updating this field correctly, it's not reliable. And that can lead us to a problem around missing possible updates. There's also a possibility of missing incremental updates. So I can run this query and maybe I run it once a day, maybe I even run it every 5 minutes. But even at that cadence, I'm going to lose all the incremental little changes that are happening in between. I'm not going to get all the changes, which might have like analytical value for your business. Then to actually run this in practice, you want to parallelize it. You're going to be running all these queries against your operational database that's competing with actual operations of your business. And that's not what we want. We don't want analytic strain to have an effect on your business operations. And finally, we can't ask the database what's no longer there. So if you're doing deletes, and there's lots of reasons why you might want to delete stuff from your database, we can't actually run a query to get what's no longer there effectively. So there's no delete capture. So the other method that we can use is streaming. So we use streaming to get more accurate updates. We want all the updates. We want lower latency, and we want to capture those deletes. And this has been done for several years, decades, in the context of database replication. It's really common for people to have a read replica. So to understand streaming and data analytics, let's first understand how data is replicated in a database. So say I have the source database, I'm inserting data into it, I'm updating data in it. What will actually happen behind the scenes is that all the state changes are actually being recorded in what's called a binary log, or bin log for short. This binary log is a transaction log of everything that's happening to the database itself. And to some sort of replication service, it essentially gives you instructions of how to change the state at your target. So it gives you the instructions to actually replicate those state changes. So this can look a little bit like this. So I have a database, I'm going to insert a row. Now let's look at what that binary log looks like. It's really messy. It's like almost not even human readable. There's a lot of stuff in here. We have information about log position. We see timestamps being set for the transaction. We scroll down a little bit. We see the actual insert that's taking place. And again, some information about the log position in the file. So that's the create case. Here's an example of what it might look like for an update. So I'm doing the update in the database. This is the bin log event, very messy. Bin log position. Again, some timestamps being set by the database for the transaction. We scroll all the way down. We can see the update that's taking place. And this is actually interesting because I can see the full state before and the state after. And then finally, the end log position again. So now we see how changes are being recorded in the database. We want to get them out. Now there's a number of services and products on the market that can solve the end-to-end story for a business, or maybe a partial section of that story of getting changes from the database, from this binary log, to something like Iceberg or your data lake. Like there's Fivetran, Debezium, even like Amazon has their like DMS, bin log, change log, dump into S3. But I'm not going to make any recommendations for your business, but things you want to consider are always, what's your target catalog and storage? What's the complexity of your business operations? Like going from a database directly, like one database to storage is one thing, but what if you have a whole fleet of like MySQL databases? Things can get quite complicated fast. So we have to understand those unique business requirements. Now, I'm going to use Debezium as an example for us to walk through end-to-end what this might look like for an individual, for a business. So I have my source database, I have these inserts, I have these updates, they're getting recorded in my bin log. And similarly with the database replication case, now I have Debezium. I have Debezium looking at these bin log files. They're parsing these bin log events and then making them readable and publishing them to some sort of target like Kafka. And these events will be in the form, will be annotated with like create, update, or delete, depending on what kind of action took place in the database. So this is what a message might look like. So we'll have a payload. In that payload field, we'll have the before and after field. So that before and after in the bin log is actually getting parsed out, and I can see the entire state. In this source section, I'll have information about the database itself. I have the database name, the table this event is coming from. We'll have a timestamp that represents when that transaction took place in the database, bin log file and its position. All that information is here. And finally, we have the operation code. So we have a U here, which represents an update. And then finally, a timestamp that represents the ingestion by Debezium. So regardless of whether you use Debezium or not, you should end up with something similar to this, with information about the before and after, where you are in the bin log, as well as the operation and when the extraction is taking place. So let's explore op a little bit. So op is the operation that took place. So a create event looks something like this, where we have null as the before value because we don't have a state for that row before, because it's the first time it's being created. We have after being populated, and the opcode is C. An update looks something like this. We have before and after being set, so I can actually compare the state change that's taking place, and opcode is U. And then we have a delete. So this looks really similar to the create event, but before is updated, has the updated state, and then after is set to null, and the opcode is D. Now there's one other kind of event that you can see through Debezium and possibly some other kinds of tools that you might use for CDC extraction, and that's a read event. And read events are actually not being produced from the bin log. They're actually manufactured by your client. And the reason you want to manufacture these events is that you might want to perform a snapshot. So you want to do a backfill of the initial state from your relational database to your target. And there's two ways of actually performing this snapshot. You can do a blocking or an incremental. And what's important to know about the incremental, and I'll go into this in a second, is that when we do incremental backfills, we have to interweave these queries that we're doing against the database with live events. And we need to be able to intelligently pick which event we're going to put downstream. So this will become clear when we walk through an example. So performing a snapshot, we're going to run some sort of query against the database. So very similar to our incremental batch ingestion use case. So select star from my table. Maybe we have some sort of like where clause where we're picking a section of the table to backfill. When I run this query, I'm going to create what's called a snapshot window. And in that snapshot window, I'm going to buffer the events I'm creating based on what I queried from the database. So in this case, I have a primary key 1, 2, and 3. Is they will always take the live event over the snapshot event because we're querying the database. We're not able to guarantee ordering anymore, which is why we create the snapshot window. So we see that primary key 1 is also seen in the bin log, so is number 2. So only this snapshot event, PK3, is the only snapshot event that actually makes it to the final output. So just to change gears a little bit, I want to talk about timestamps, and timestamps are really, really important. It's really important to understand your infrastructure and how your timestamps relate to your infrastructure, and this will be helpful later on. So I mentioned the before and after field. Before and after represent data from the columns of your database table. So any timestamps that we might see there, like a created at, an updated at, these are set by your application code. They're not set by like the database necessarily. They're not set by Debezium. Then we have your source, TSMS. So anything in source is information coming from the database itself. So here, this timestamp represents the timestamp of the database when this event was created, when this transaction took place. And then finally, outside of that, we have a timestamp of the extraction time by Debezium. Regardless of what system that you use to do CDC bin log extraction, you should always have information, timestamp-wise, around what's happening in the database and also what's happening in terms of extraction time, because there can be a delay. So we want to get from that to the lake. And Debezium is a tool that dumps data in Kafka. So we'll talk about what happens when you put data in Kafka, but there are a variety of tools that you can use to actually pull it out. You can use Flink, you can use Kafka Connect, but regardless of what tool you use, what we're going to talk about today is still relevant. I want to talk about ordering and consistency. So I have these bin log events. Debezium is extracting this data. It's landing in Kafka. What we're going to do first is do a table fan out or topic fan out. We're going to want to have a topic per source table. So that means when I look at a topic in Kafka, all the messages in that Kafka topic represent the changes from a single table in my database. The next thing to consider is the partitioning within that Kafka topic. So it was really nice looking at the Debezium output. I have all the messages in order, but once I put them in a Kafka topic and that Kafka topic is partitioned, now those messages could go across several partitions, and I'm going to have to consider my topic partitioning. So my recommendation is always partition on your primary key so that you can guarantee that all the messages for your primary key, for a single primary key, land within the same partition. The other thing to remember is regardless of what tool you use, Flink, Kafka Connect, typically the way these tools work is you'll have an independent consumer for each of those partitions. So now we have independent consumers writing their own files to a table, and we have downstream consumers who will read those tables. How do we make sure they get a consistent view of the world? So here's an example of my Debezium output. And my data is getting separated between two partitions. Partition 1 has all the odd primary keys, and partition 2 has all the even primary keys. And I want to know what the world looks like at timestamp 4. So to do that, on partition 1, I need to consume and publish everything up until offset 3. And on partition 2, I need to consume everything up until offset 1. Somehow, downstream, I need to be able to communicate that no one can consume data or shouldn't consume data past timestamp 4. Because if they do, they could view an inconsistent view of the world, because I can't order events between these two partitions beyond this timestamp. So the way that we do this is normally having some sort of watermarks that we provide to downstream consumers so they know how to filter our downstream table. Maybe you have a view in front of your changelog table so that people can only consume the max of the min. So min of the max. So we talk about min of the max database timestamps across the partitions. Database timestamp is the one that we want to rely on in ordering across the partitions, because that's the thing that's true about the database. So we want to look at that timestamp across the partitions we've consumed from. We want to create some sort of view so we only see the data up until that timestamp. Now, this gets really hairy when we think about out of order events. When we talk about backfilling old events, late arriving data, even duplicated data, creating some sort of watermark of absolute consistency is near impossible. So my recommendation to anyone who's like in the position of ingesting this data and making it available for downstream analysis is set the expectation of eventual consistency. And make sure that downstream people build their pipelines with that understanding. Because there will always be a case to backfill data. There will always be a case where something will go wrong between all of these different distributed systems trying to work together, and you will have out of order events. As much as systems try to promise that they're absolutely consistent, it's actually very, very hard to guarantee that in all circumstances. So we have our changelog table, and usually what people want out of the changelog table is actually a snapshot. And what I mean by snapshot here is the view of your source table at a specific moment in time. We want to take all these changes and apply upserts to some sort of target table. So we only have one row per primary key. So to do this upsert, to do this merge, you really have to understand your infrastructure and your timestamps, because that's going to become really important right now to figure out how to apply the update. So the first thing to do is to get your new chunk of data that you want to merge into your target table. So to do this, we're going to select data from my changelog table, and I want to grab all the data since the last time I processed. So to do this, the timestamp I'm going to use is my extracted at timestamp. So in this case, it's TMMS, which represents the timestamp Debezium saw the data and extracted it. So this is all the new changes. Then within this chunk, it's very likely I'm going to have multiple rows per primary key, because there could be tons and tons of changes in there. So I need to deduplicate this. So the way I'm going to deduplicate it is to run a window function over the primary key, and I'm going to order and select the one with the latest database timestamp. So this is my source, TSMS. And I'm choosing the database timestamp because it's always possible that I could have extracted data out of order. So to make sure I pick the right one, I'm relying on what happened to the database, that information. So now that I have that chunk, I need to upsert it into my target table. So the way this will look is something like this. Iceberg supports like a merge statement, so we can merge looking at the target and source primary keys. When they match, we can look again at the database timestamp. So this is the source TSMS. And if the one from my chunk is greater than my target, then I can update the row. If my opcode is D, I can delete the row from my target. And if I don't see that PK at all in my target, that means it's the first time I've seen it, we can insert that data. Now, there becomes a caveat when we have late arriving data. So here's an example where if we look at batch 2 over here, I see that there was a delete event. But then if I look at batch 3, I can see that I have this update event for the same primary key. And it's actually a duplicate of what happened up here. If I were to hard delete from my target table primary key 1 because I saw this event, later on when I see this one, I would essentially resurrect this deleted row because I have no context in my target that this ever existed. So my recommendation to anyone who has to produce these snapshots or like merged tables, merged CDC tables, is to employ soft deletion whenever possible. Because once I have soft deletion, that means that this row would stay active in my target table, and I can then compare the database timestamps. And when I compare the database timestamps, I can see this one in batch number 3 is actually old, and I can ignore it. So yeah, that's my recommendation. Always use soft deletion when possible. So the final point that I want to make is around cost control, around doing the merge. So the merge operation is very expensive. And we talked about this in length in our previous webinar, the ingestion webinar. But just as a recap, when we talk about syncing data in our data lake, when we write data in our data lake, it's usually in some sort of columnar format. And columnar files are immutable. So that means it's quite expensive to actually update the data within them. So we want to actually limit the data we have to scan and the data that we have to rewrite to perform the merge. So there's a couple levers we have to controlling, giving hints to the query engine. We can partition our target table. We can partition our table by something like Kafka partition. This doesn't always work, but if you're planning to never repartition your topics, that's a valid option. Or maybe there's some sort of operational business column like org ID that you can partition your target table on. You can only do this when you know that for a given primary key, it will never change its org ID. You can also turn on merge on read, which will change the way the data is being inserted. So it'll attempt to write these delete files instead of rewriting the physical data files over and over again. And finally, consider how often you actually need to perform this merge. Do you need to perform it every 5 minutes, every hour, every 6 hours? Performing the actual merge is quite expensive. And you do have all those changelog data around. So you can create a view of your previous target and incorporate that changelog data in a view so you don't have to rewrite this data all the time. And actually, Tabular has a great blog post around how to do this exactly. So some opinionated architecture takeaways. So if there's anything that you take away from this call, it's that the whole system of ingestion is actually quite fragile. It's fragile because of all the distributed systems that are working in tandem together. You have a MySQL database. It might even be a MySQL fleet. So things get more complicated there. You might use Debezium. Debezium is a distributed system. You have Kafka. You have Iceberg or your object store or your other data lake tool. All these different systems need to talk to one another, and they all talk different languages. They all have different ways of, they all have different consistencies and operational models. So things are fragile. Understand your infrastructure, understand your timestamps, support eventual consistency. These are like my 3 most important takeaways. Employ soft deletion on your target table so that you don't resurrect old data, and to leverage merge on read, partitioning, and how often you rewrite your data to reduce cost. Yeah. That's all I have. Thanks.
Awesome, Vicky. That was fantastic. I learned a lot as always, so thank you. Lots to consider there. I'm glad this is recorded because I think I'm gonna have to go back through it a couple more times to make sure I captured everything. But there's also a number of good questions in the Q&A. I can sort of read these off. So the first one, which I think you covered, but I'll just let you, maybe expand on it, is do we need to add timestamp column at source for CDC?
So I'm going to assume when they say to add a timestamp column for source, that it means like from the database, like do you want to add a timestamp to your table? That's not necessary, but for your downstream table, like for your Iceberg table, I always recommend keeping all of these like infrastructure level columns. Keep your source timestamp, your database timestamp, keep the extracted at timestamp. And the value of keeping that around will be later on in the future when something goes wrong. You'll be able to tell and create a timeline of what happened in what system. So I would always recommend keeping whatever infrastructure timestamps around. And if you don't want data scientists to build on top of that, you can always create a view in front so they're not querying that infrastructure level data.
Makes sense. I'm not sure this is one you can answer, but the next question is, does SQL Server support streaming as shown for MySQL? So I don't know the internals of SQL Server's bin log capabilities, but.
So I'm not sure about SQL Server, but if you have a MySQL, and there's lots of relational databases that support exactly what I showed, so like MariaDB and like other databases, so they may not call it like a bin log or binary log, but all relational databases should have something similar to what I had shown. And the purpose of that is for database replication. This is how like databases will talk to each other.
Yeah, it does get more complicated if you have distributed relational databases, like Aurora type stuff, but it can also be done. So next question here is about the timestamps. Are they really millisecond or are they actually second level precision? Again, this is probably going to be database dependent, but I don't know if you have any more.
So this is both database because there's 2 timestamps, right? So there's one from the database and there's one from Debezium, whatever is like extracting. And all those timestamps and their precision is configurable. So you can always like configure MySQL to produce nano level precision if you want. But then, that might require like a fallover of your MySQL fleet. So you have to put that into consideration. So you might say, oh, like I don't have the political will to make that happen in my organization. So you know what? I control Debezium or I control the extraction layer. I'm going to have nanosecond precision there. So what I showed was millisecond precision, but if you go through the documentation, you can actually control the precision level you want.
Awesome. A question here about what do you mean by partition by primary keys?
Right. So in Kafka, you can have different partition strategies. So what you can have it do is look at the primary key, what you've configured as the primary key in your message. So you say, hey, look at, okay, so one thing I didn't go over in terms of Debezium is when it fires a message to Kafka, you have the message and you have a key portion. And the key portion, you can actually designate what you want that key to be and whatever the value of that key is. So say like you configure it to be your ID column of your table. And then on your Kafka topic, you can specify a partitioning scheme. So partitioning scheme could be based on that value. So it could hash that value. So then all my ID1s will appear on the same partition. ID2 will probably go to a different partition. So you have this like hashing partitioning scheme. You can also do round robin, where basically you're alternating. Message 1 goes to partition 1, and then message 2 goes to partition 2. And you might want to do this for like event data so that the partitions are evenly distributed. But when we care about the ordering of events, that's when you want to partition on like a specific field, and you want to use something like a hash partitioning function in Kafka.
Yeah, definitely having all the records from the same primary key show up with the same Kafka partition has a nice property. You touched on it a little bit, right? But trying to make sure that your downstream reads are actually transactionally consistent, it's very difficult to do. These tricks do help. And even then, you can't be guaranteed that, like to your point, that the ordering of the events in that partition is actually matching the ordering, that came off the database. So lots of things to consider to your point about eventual consistency and the challenges of, distributed systems. The next question is less of a question, although I think there's some good stuff to go into here because I'm not sure you touched on it, which is what happens when you have, source timestamp values, database timestamp values, that are the same for the same record. What are the tie breaking mechanisms here? The question mentioned the opcode, but there are other things to consider, I think.
Yeah, so there's a lot of things to consider. Like one is if you don't repartition your topics and you're fairly certain there wasn't any like weird infrastructure, distributed system errors, backfills happening, you can look at the order of the events in Kafka. Like that's one option. You can look at the timestamp where Debezium extracted the data. So that's something you can always fall back to. Now, because they're timestamps, we have the precision problem, right? So if the precision wasn't enough in your database, is it enough in Debezium or your extraction tool to actually decide which one to pick? So you have that, you have the ordering of the events in Kafka, in the Kafka partition. After that, it gets very difficult. You need more hints. So yeah, that's the ordering I would take. And after that, you have to like think hard if there's like hints that you can take, whether it's opcode, it's like if I see a delete, most likely you won't see an update afterwards. Like that's an easy one you could probably prune out. But you want to take as many hints from the infrastructure to understand what's happening and set up your infrastructure in such a way that you're getting all the right information to deduplicate properly.
And in some instances, you can get maybe a transaction ID or something from the
The
database.
transaction ID, like we have bin log file, we have bin log position. You can look at that. Those files do get rotated. You a GTID. We didn't get into that. That's like a MySQL specific or database transaction specific thing. So you can order based on that. But now we're getting like into the weeds, more into the weeds of like MySQL transactions and understanding what's happening there. So if there's any takeaway, it's like to do this job properly, you have to really dive deep in the infrastructure and understand what's going on.
Understanding infrastructure. Absolutely. Okay. Can you clarify what you mean by repartitioning Kafka topic? You mentioned repartitioning just quickly. And it's maybe a whole different like webinar we can do on Kafka partitioning, but just quickly.
So this is interesting. And this actually, I mentioned this specifically because there was someone who had a question about ordering in the last webinar, and we had a conversation afterwards about ordering your events in Kafka. So when you repartition your Kafka topic, so for example, you start your Kafka topic, it has 10 partitions, and your business scales, and you say, I need more partitions on my Kafka topic to scale this out properly because I need more consumers, parallel consumers, right? It's all about parallelism. So I have this topic and it goes from 10 partitions to 20 partitions, right? But now what's going to happen is the hashing function is changed. So now there are 20 buckets instead of 10 buckets. And I'm no longer going to guarantee that originally ID 1 was going to partition 1. Maybe now it goes to 5 because there's more buckets the data is being split up into. There's more partitions. So that's what I mean by when we think about how we should partition how you should partition the target table, right? We're partitioning the target table to make sure all the same IDs go into the same partition. The same has to be true for your infrastructure. So if it's not true for your infrastructure, then you can't partition by like Kafka topic, or sorry, Kafka partition and your target table. You need to partition by something else. So that's why I offered the alternative of like maybe you have org ID. And org ID is always going to be consistent. Like you'll have the same primary key going to the same org ID all the time.
I know in tabular land, we also use like the Iceberg's bucketing partitioning strategy, right? Iceberg has a bucketing partitioning strategy. You can say bucket 16 buckets based on my primary key, right? And then if even your Kafka partitions change, like at least your Iceberg partitioning strategy will be consistent, which can help. It's challenges.
Yeah, it's challenges. And like even in the Iceberg case, like what happens if you migrate your partitioning? So now it's no longer 16 buckets, it's now 25 buckets, right? So things.
Yeah, stay on powers of 2 and you'll probably be okay. Next question is about soft deletes. And I think sort of the question gets around like, do you just create a view where like op is not equal to D? Like if you're using the soft delete strategy, maybe some additional, do you want to partition on your soft delete Boolean flag or up column and maybe create views? How have you handled that in the past?
So in the past, I love relying on views. I think views are very, very powerful. You have all the raw data, all the data in your raw table is being operated on, you're in control. And if someone does not want to see the soft deletes, they want to see the true version of the table of how it looks like in your database, just create a view where you ignore those op equals Ds. That's the best thing to do. Because at the end of the day, like you don't want to rewrite the table and have duplicate of the table around, right? Like you don't want that, but you also you want to keep that old data around so that you can operate and apply updates correctly. So create a view. Create a view.
Views are your friend. Agreed. A good question here about the trade-offs between merge on read, because you mentioned that, versus copy on write. Any recommendations you want to share from your experience on, the trade-offs? When would you use one versus the other?
Yeah, this is going to be, I don't have any like clear recommendation of like, if you've hit this threshold, this is what you should do. What's happening with merge on read is that you're paying the penalty at query time to perform the merge, right? So you have to figure out for your business and the number of changes that are coming in, what is my tolerance for that degradation for that like degrading performance at read time. And, think about that in like magnitude of seconds and minutes and do some experiments. And that can affect like how you want to then go back and rewrite the data files. So I think it's on a case-by-case basis, and you have to figure out what's your tolerance for that degradation or degrading performance.
Yeah. And just another note, you have to make sure that if you are using a merge on read strategy, you have some other system that's coming back through and compacting those, delete files eventually, right? If they do stack up too far, it definitely hurt your performance. So there's, I think, more moving parts if you're going to use merge on read. So there's trade-offs. How do you handle updates to the primary key was a question. I think we covered this, but
Maybe I can talk about this just a little bit. I in a past life, I would always treat updates to a primary key a breaking change, like a breaking schema change, because it changes the way that I need to operate on the data and think about my data. So it's really hard. I would typically in the past, I would do the very hard thing of having, change in PK means different tables entirely, and I would have to go back and backfill. I would have to do those snapshots, incremental snapshots, re-backfill all the state, because I don't know how to interpret the old data anymore. So that's the safe route, but also brute force. Breaking schema changes are hard. Yeah. And I always consider a PK change a breaking schema change.
Agreed. I think that's good advice. And we got confirmation SQL Server does have a bin log replication. So thank you to Jocelyn for helping us out with that one. All right. I think we've covered all the questions. Thank you very much, Vicky. Again, this was recorded. We will be sending the recording out the following days. As long as you registered, you'll get it via email. And there, like Vicky mentioned, a number of great like CDC blogs on the Tabular website as well around how to use views, how to make sure you get transactional consistency with your upstream database. Lots of good stuff there if you want to dig in. And thank you again to Vicky for doing this great presentation. I learned a ton. And thank you all for joining us. And hopefully to see you on the next one. Have a great day. Bye.